Okay, I hear we need to go through the chain rule again, especially when it gets a little more complex. So we're going to go top to bottom on this. We're going to start at the beginning and go through it again. Let's do more examples. Let me throw some color in there. We'll see what we can do, okay? This, just for the record, is not worth panicking about. We're going to get it. We're going to figure it out. We won't move on until we do. If we need to make 1,000 videos, we will. We're going to get it. If we need to have a little Zoom session, we will. So let's start over. I'm going to talk really slow. Or I'm going to try to. Do you like my flamingo? Eli asked me today if flamingos can fly. And I don't know. Does anybody know the answer to that? It's a good question. I know they're pink because they eat shrimp, and that's what gives them their color. Okay, focus. Okay. All right. Let's go back to basics. If we have a blue heart squared, and we want to take the derivative of that, we would say the derivative is 2 blue heart, because that's product rule, right? Now, the question becomes, what if that blue heart is actually a different function? What if that blue heart was actually 3x squared? Then the derivative would still be 2 3x squared. Does that make sense? And then where the chain rule comes in is it says you now need to take the derivative. Do you remember how d dx means derivative? We now need to multiply by the derivative of 3x squared. I feel like I just confused you. I'm going to keep going with this. This notation is actually how they write it in textbooks a lot. So what is the derivative of 3x squared? Well, the derivative, let's rewrite everything we know. We know 2 3x squared. And now we need the derivative of 3x squared, which of course is 6x. So now we have 2 times 3x squared times 6x. If I multiply all that together, I get 2 times 3 times 6 is a big number, 36. X squared times x is x cubed. Fair? Okay. Let me explain that a different way. Let's take y equals 3x squared squared. If we want to find the derivative using the chain rule, what we say to ourselves is the derivative of the outside times the derivative of the inside. Okay, that's what we say. So in this case, our outside is something squared. And our inside, I need a new green. Our inside is 3x squared. So we're going to take the derivative of the red part. What is a derivative of something squared? The derivative of something squared is 2 something to the 1, right? Well, that 3x squared is still in there. I'm just going to dump it in there. So that's the derivative of the outside. Now, what is the derivative of the inside? The derivative of the inside, the derivative of 3x squared, is 6x. There's no addition or subtraction, so I can multiply that all together. 3 times 2 times 6 is 36 x squared times x is x to the third. Derivative of the outside times the derivative of the inside. What if I make that a little more complex? What if I say y equals 3, 2x to the third plus 4x squared. Okay, so here's my problem. First thing we need to do is find the outside. Well, the outside is this. Literally the outside. What if for right now I just forget my 2x cubed plus 4x? Okay, what is the derivative of this thing? Well, the derivative of this thing is 6 to the 1, right? Because I multiplied my 2 to the 3 and dropped my exponent by 1. Well, what was inside? Now I can't remember. Seriously, this is why I need people in front of me. What was inside? Hold on. Okay, it was 2x cubed, 2x cubed plus 4x. So now I'm going to multiply by the derivative of the inside of the green part. What is, and because there's brackets, or because there's an addition sign, I need brackets. What is the derivative of 2x cubed? It is 6x. What is the derivative of 4x? Plus 4. Derivative of the outside times the derivative of the inside. Now, this is the unsimplified version. You can clean that up. You can multiply the 6 into here. You can multiply this together. Let's not worry about that for right now. Let's leave things unsimplified until we can see them. Let's do another one. And remember, if you want to stop and hit pause and try and solve these, have at it. Okay. What about this? Okay. This is chain rule. If I rewrite this in exponential form, or an exponent form, I turn that into a half. Okay, I am going to I need to figure out where my inside is. My inside is literally inside, x cubed plus 5x. So right now, I'm just going to focus on the green. The green is my outside. What is the derivative of 2 something to the 1/2? I'm going to multiply my half times the 2, right? Just like product law. Well, 2 times a half is, 1. And a half minus 1 is negative a half. The inside is still there. I have not touched it. Okay, now, I'm going to multiply by the derivative of the inside. My red part. What is the derivative of x cubed? 3x squared. What is the derivative of 5x? Plus 5. Done. Now, if we're going to clean this up, which we should, I need to just pay attention to this negative 1/2. That just means the negative is going to send it to the bottom and the half is going to make it a radical. So I'm going to draw myself a giant fraction and I'm going to send that whole part to the bottom. I'm not going to write in this 1 because it's a 1. This is still on top. It doesn't have a negative exponent, so it's just going to live on top. And we're done. Okay? Okay, now, are we feeling okay about that. I hope so. Okay, let's put some product law in this. Okay, so y equals, I don't know, x squared plus 3x times x to the third minus 6x squared. Okay, I'm going to come through and I'm going to color this. I'm going to make the red my, oh, I bet you can't see that. Oh. I'm going to make this my f of x for product law purposes. And then over here, let's make this x cubed minus 6x squared. Let's make that our g of x. Oh, duh. Okay. I'm going to square this whole thing, and I'm going to cube this whole thing. Okay. Did everybody catch that I missed? Those little exponents are what make this need chain law. And the fact, or chain rule, and the fact that there's two of them is what makes us need product law. So we have to use product, and we have to use chain because of these exponents. So I'm going to try and write this kind of small. All right. So product law says that the derivative is going to be g times f prime plus g f f g. Okay. So g is going to be in green, right? Red is going to be for the f. Oh man, I hope I can draw small enough. Okay, here we go. G, we're just rewriting g. So x cubed minus 6x squared cubed. F prime, I need for this one to take the derivative of this, but I have to do chain rule. So I have this x squared plus 3x squared. Well, what is the derivative of something squared? The derivative of something squared is 2 times that something, right? I'm not even going to bother to write it in. Okay? And then go back and write it in. X squared plus 3x times the derivative of the inside. What is the derivative of x squared plus 3x? 2x plus 3. Okay? F of x is just x squared plus 3x squared. I'm just rewriting that. And g prime. For g prime, same deal. The inside here is x cubed minus 6x squared. So just look at the outside. Something cubed. This green blob cubed. What is the derivative of that? Well, it's 3 green blob squared. Write in your green blob. Now we're going to multiply by the derivative of the green blob. Well, the green blob's derivative is 3x squared minus 12x. Okay? So that's the ugliest thing I've ever seen in my whole entire life, but it's the unsimplified version. Now, keep in mind that when you go to clean something like this up, you can't multiply across the addition sign. So all you can do is do multiplication on either side. Like in this gray box, you can multiply stuff together that doesn't have an exponent. And in the orange box, you can multiply stuff together that doesn't have an exponent. So here, like this has an exponent, so we can't do much here. But we could multiply this 2 into the x squared, right? And then Maybe we can even multiply that together. I don't know. That seems excessive for right now. Let's just rewrite this as x cubed minus 6x squared cubed. I'm going to multiply this 2 in, and that's going to give me 2x squared plus 6x. And then I still have 2x plus 3. Over here, can't do anything. This has an exponent, so we're just going to leave that, right? And then in here, we can multiply this 3, not into that because it has a squared, but we can multiply it into here because this does not have an exponent. So we could say, so I'm going to multiply this 3 into here, which is going to give me 9x squared. And that 3 into here, which is going to give me negative 36x. And then we still have this guy. X cubed minus 6x squared squared. What a mess. Okay, should we do another one? I feel like this is the longest video ever, but maybe that's just how it goes. Let's do another one that's a little bit shorter. What if we have 2x times the square root of 4x squared? So this is product law as well, because look, we have a 2x times 4x squared. So if we rewrite that, and we now know that that 4x squared is actually 4x squared to the half, right? So red is going to be our f of x, and green is going to be our g of x. So y equals, or y prime, we're going to go g, f, f, g again. So g is just the square root of 4x squared. F prime is just 2. We don't need chain rule on that, which is great. Plus f, which is 2x. That's nice. And now g. So here's where it gets tricky. G has an outside and an inside, right? It's got a red blob inside. So what is the derivative of the outside? The derivative of the outside is 1/2, is 1/2. And if you want to put if you want to put square brackets because that helps you, then do it. It kind of messes with me. So I'm going to put brackets around that half because it's being multiplied, times the inside to the negative half. Well, my inside hasn't changed. It's 4x squared. Now I need to multiply by the derivative of the 4x squared. What's the derivative of the red blob? 8x. Okay. And if we clean that up, I'm just going to put the 2 in front. And over here, let's see what can go together. This can multiply, and the 8x for sure can. Now, if we do that, 2x times 1/2 is just x, times 8x is 8x squared. Am I doing that right? 8x squared. And then this dude needs to go to the denominator and a radical. And then we're done. How do we feel about that? I hope okay. Okay, let's look at quotient. If we do quotient rule, let's see. x squared plus, I don't know, 4x squared over 2x plus 3 cubed. Okay, so the top is f of x, the bottom is g of x, and then within the top we have an inside, and within the bottom we have an inside. Okay, so there's 4 things at play here. What a disaster. Okay, so f of x is on top, g of x is in the bottom. They will both require chain rule. What might be easier at this point in the game is to go ahead and take their derivatives before you even start quotient law. So that way you're just ready to go when you do quotient. So if we just look at the top, like if we completely ignore the bottom, what is the derivative of this? Okay, so we're going to take the derivative of the outside. So we're going to put our 2 in front, 2 to the something, and then to the 1. So then I can go in and write my x, what is it? X squared plus 4x. Now I'm going to multiply by the derivative of the inside, which is 2x plus 4, right? So that's good. And if I want to clean that up a little bit, I can say 2x squared plus 8x times 2x plus 4, right? Okay, so this is my f prime of x. So this is useful. Let's keep this. Here's f prime. If we do the same thing for g of x, oops, if we find g prime of x right now, over here, I have a yellow blob cubed. What is the derivative of a yellow blob cubed? It's 3 yellow blob squared. And my yellow blob is 2x plus 3. Okay, now we're going to multiply by the derivative of the yellow blob, which is 2, right? 2. Okay, clean that up. This 3 and this 2 can multiply together because they're just whole numbers. They don't have exponents. So 6 times 2x plus 3 squared. And here is my g of x. Okay, so right now I'm going to go back. I'm going to make this all red. So here's f of x. Oh man, make it all gray. Here's f of x. Here's g of x. Here's f prime. Here's g prime. So now all we really have to do is plug that into our quotient rule. So let's make this smaller. So quotient rule says G, F, F, G, and we're going to subtract. So G is 2x plus 3 cubed. F prime is 2x squared plus 8x times 2x plus 4 minus F, x squared plus 4x squared times g prime, oh dear, 6 times 2x plus 3 squared, all divided by g squared. Okay, so careful here. G is 2x plus 3 cubed, and then you need to square it. And that, my friends, is what we call a mess. But it's the right answer, so that's fun. Okay, listen. I hope this helped. If it didn't, my suggestions would be to Google chain rule and find another math teacher out there who's got videos that maybe can explain it in a different way that makes more sense to you. Or I need you to comment that you still don't get it. If there's, and then we'll Zoom or, I don't know, FaceTime or do something, figure it out. Okay, I think you guys are wonderful. I really don't want you to hate this. I know it's tough, but we can do this. Okay. Oh God, that's ugly. Okay. Bye.